Okay, cool. Hi everyone. So we are starting our first online Chuck lecture in this new strange world that we live, where we all stay in single rooms, and Backblaze shouts at me every 5 minutes. So this is, oh my god, nothing but texts. This is obviously going to be slightly less formal than normal, and I don't think our class has ever been particularly formal, but we're going to have to kind of get used to this and learn as we go and give each other space to figure this out. So for me, that's going to be getting these videos out on time and making sure the audio quality is good and generally giving you everything I can, and from you, take as much time as you need. I'm going to try to ramp us into this slowly and keep things not simpler than they would be, but less frantic, and maybe cover smaller things than what we usually would in class, where we kind of end up trying to build some giant complicated thing. So that said, I want to start talking about Midi. As I said in my email earlier this week, and I will say again in the subsequent emails when this video goes out, my plan is I'm going to try to teach this class, and Mike as well. I don't know how we're going to split it up. I don't know if it's easier. I don't know. But the plan going forward is to basically do pre-recorded lectures like this, hopefully no more than an hour, hour and a half, and then do essentially office hours on Zoom. So however long, so our class time is 2 hours, right? So if I do an hour-long video lecture, I will also, on Wednesday for class time, I will hang out on Zoom for an hour. Everyone can come, we can talk, you can ask questions, we can go over stuff, or we can just like hang out and, casual, chill, give everybody some face-to-face contact. That's the vibe. I hope that works. If it doesn't work, we'll change it, but I think that makes the most sense, at least from the get-go, as we're dealing with external audio and controllers and microphones and all this stuff, and I don't want to do that in with the blur of like Zoom or Google Hangouts like getting in the way as well. So I want to jump right in so we have enough time to get to everything and we can kind of go at a reasonable pace. Okay, cool. So Midi. You'll notice by my like double cam setup that I have a Midi controller here. For anyone who's unfamiliar with Midi, what Midi is essentially an open standard, standard of communication between musical devices, developed early 80s, I think, by Dave Smith of Sequential Circuits fame. And really all it is it's just a super dumb protocol that allows kind of meaningful messages to be sent between music hardware developed by different companies. So those messages might be like a note on, like a C was played, or like that C was like lifted up, we stopped playing that C. Or it might be a pitch bend or a transpose or a mod or whatever else, it could be anything. But there are many predefined things, and there's kind of a structure to this message, and it's super, super, super simple. It's not a complicated protocol, as you can imagine if it was developed in the 80s. So we're going to learn Midi today. We're going to learn basically how it interacts with Chuck. As far as Midi input goes, we're not going to do Midi output. It works very similarly, but it doesn't really make sense for me to send Midi to something, because the thing you want to send Midi to will work a different way. So you kind of just have to like learn it as you go. We're going to do keyboard. Depending on time, I may bust out something with some faders on it, but again, it's pretty similar. And I'm going to try to show the general flow for like working out how these things work, so that hopefully whatever you plug in, you can figure out how to do it, rather than me explaining like a keyboard and a fader and a knob and an encoder and a pitch bend and all that. That's my goal. And if you don't have a Midi controller, I suspect most of you have something, but obviously not everyone will. If you don't have a MIDI controller, it's not required. I'm also going to show how to do this sort of thing with the computer keyboard and the mouse and stuff, so you can also use that. I think I'm going to probably split this lecture, so I'll basically teach stuff twice, once the Midi version and once the HID version, so you only have to watch one of them. You can watch both if you want to learn both, but you only have to watch one of them to get through this week. Okay, so I have, an empty folder called Midi. This is where I'm going to write my code. I'm just working with one file today. We're not loading any sounds, so there shouldn't be any like crazy terminal VS Code problems. Like, as long as you can run a file, you're good for this week. So I'm going to create my MIDI tester.ck file. That's what I'm calling mine. And we need to kind of lay out some groundwork for how Midi works. Midi in Chuck relies on a system called events. And the idea of an event is, excuse me, I'm going to burp. It's very unprofessional. The idea of events in Chuck is it's kind of a different timing system than the one we've already used. So we've used this kind of built-in, like, wait for 1 second, wait for 2 seconds, wait for 100 milliseconds, wait for 1 hour, this kind of thing. Which is great when we know when things happen. But when we're working with something like Midi, it's like, I don't know when I'm going to press the button. I kind of just want to do something when the button gets pressed. It's not relevant to me if the button is pressed in 5 seconds or in 10 seconds or in 20 seconds. Like, I just want when the button's pressed, do a thing. And that's what events let us do. They let us wait for something rather than wait for an amount of time. We can just wait for a thing to happen. The event system is how OSC works in Chuck. It's how Midi works. It's how HID, which is your keyboard and mouse and shit. It's how Serial works. It's probably how network stuff works. It's a very powerful system. It's also a system you can hook into and create your own events, custom events, have things wait for them. And it's my preferred way of building larger pieces of code in Chuck, like kind of wrangling larger applications. We're not going to do any custom event stuff. We're just going to use the Midi events, but we will, going forward, likely get into custom events at some point. So it's important to explain vaguely what they are. So that said, there is some boilerplate we need to do, and it's going to look a little bit weird. There is also an example. If we go into Mini Article, there is also an example. If you go to Open Example, Midi, Go Midi. And here you'll also find some other stuff. But Go Midi, this is your basic Midi example. I might just copy the whole thing in. We'll just copy it. We'll copy it by line and go through each line as we go. So the first thing is we have an integer that they call device. This is going to be used to determine which Midi input we actually want to talk to. So if you have multiple Midi devices plugged in, you have a keyboard, if something else, this is going to be how you know which one you're talking to. The second thing they do is they do this if me.args SCDA to chuck to device. You can safely ignore this. What this means is that if I were to chuck Midi tester and then I gave it some other information, so I said Midi tester 2. This 2 would pop up in this array, so they could then say, oh, device 0 was the default, but when they ran the code, wanted to load device 2. But you can ignore that. I don't use it. You will see it in examples from time to time, though. Then we have Midi in and Midi message. So Midi in, min, Midi message, message. These are the two key parts of how Midi works. Midi in is essentially the Midi event. This is the thing that we will wait for. So we will chuck min to now at some point. Message is the data that's coming down the pipe. So we will allow min to use message to give us data. It becomes clearer as we go. Then we have this line. If not min.open device me.exit. And I've split it up into separate lines because it's easier for me to read like that. Do so if you wish. What this means is Midi device or cannot open Midi device. What this means is try to open device. So min has this function open, which will form a connection with whatever MIDI device you have, this will try to open it. The reason we wrap it like this, you could just say min.openDevice. This is fine. The issue here is that if this fails, it's likely that everything after won't work because we're writing MIDI code. So if we couldn't open the device, probably everything else, all of our MIDI won't work because we couldn't connect to anything. So a safety measure is to wrap in an if statement like this. If not min.openDevice, so if we couldn't open the device, log, oh shit, didn't work, and then call me.exit, which just quits Chuck, just exits the program. So if we tried to connect and it didn't work, it'll kill itself. This is good, especially if you're gonna do a live show or something. You wanna know right away, like, oh shit, my controller didn't connect, I need to restart or something. Then we have a while loop, while true. And here's the magic thing, min chuck to now. So min is not a time, right? It's an event. So min chuck to now. Then we have while min.receive message. And we log message.data1, message.data2, and message.data3. So we wait for min to receive a message. So we basically wait for min to fire, which means we got something. Then we use the message object. We pass it into this min receive function, which just sets all of the data, all the parameters. Now min has received message, and we log these three values of the MIDI message: data 1, data 2, data 3. What these values are changes depending on what kind of MIDI stuff you're doing, but this is the basic protocol of MIDI. There are only 3 bits of data that MIDI sends. 3. There's only 3 bits of data that MIDI sends. It sends what's known as a status bit, and then 2 value bits. So basically, whatever's in data 1 will kind of be like what thing you're doing. Is it node on? Is it node off? Is it channel 1, channel 2, fader, knob, whatever. And then these other two bytes are what the actual values are. And this will become more clear as we fuck around with it. So we're just gonna log them for now. I'll save, and I will run my code and see what happens. So chuck MIDI tester. Hopefully it works. It's taking a little second. Cool, it seems like it's working. I always make sure that I log after our escape. I'll log opened MIDI device, and then I'll put min.name. And there should be a plus there. Nope. What do they do? Min.name. Missing a semicolon. Of course. Of course. So now I know that it's open. Okay, so good. Opened MIDI device, arterial key step 32. And I can press some buttons. And I'll see my data coming in. Now we can unpack this data in a minute, but there is something that I've kind of skipped over. And that is what this device actually means, what it means to have an ID on a MIDI device, and how we find out what that thing is. Working from home. How we find out what that device, what that ID actually is. So the easiest way to do this is to type in the terminal chuck -- probe. Do that again, chuck space -- or hyphen or whatever, probe, and you hit enter. And that will get Chuck to basically list out everything that it's connected to. So all your audio devices and all of your MIDI devices and your HID devices and all of that will get logged to the terminal, and you can kind of see information about them. So these are the audio devices that it knows about, my microphone, my built-in out, the microphone on this camera, my mixer, which are actually using Soundflower, another Soundflower, some multi-out thing. Then we have MIDI inputs. So I only found one MIDI input, one MIDI output, one joystick device. I don't know what that is. I don't have a joystick. One mouse, which is the internal keyboard / trackpad, and one keyboard, or 3 keyboards, which is my USB keyboard, my internal keyboard, and this one that's just called keyboard. I don't know what that third one is. Maybe it's this, I don't know. The point being, you know, you don't have to know what everything is in here. Like, it's not uncommon to be like, oh, I don't know what that MIDI device kicking around is. Things you install, they run these services on your computers. Like, I probably installed something at some point that has a virtual keyboard that's forever just running on my machine now. If you install a lot of weird audio programs, I'm sure you'll have some weird MIDI stuff kicking around. But for me, I only have the one, this Arturia KeyStep 32, and that's why when I connect to device 0, this number here, it connects to this. If I had multiple devices plugged in, I'd have a 0, a 1, a 2, or whatever. You'd have to know which one you wanted to connect to. You'd have to know its ID, essentially. And the annoying thing is that the ID is not consistent. It depends on what order they're plugged in. So usually I find that ID is not a great way to go for doing this connection. So I would prefer, once you've done your probe and you know what you want, essentially, I would just copy the name. I think that got it. I would copy the name. There we go. Copy the name. And I would, rather than use an int device, I would use a... Oh my god, everything's fucked up. I would use a string device, and I would connect to, what is it, Arturia KeyStep. How is it spelled? Arturia KeyStep 32. Like that, chuck to string device. And this should all still work with the string. It does. But now it will always connect to the KeyStep. Even if I have other stuff plugged in, we're good. That's how I would go forward with that. Okay, so we're here. We've got something very basic going on. Let's dig into what these messages actually mean. Oh no, my face cam's died. Screen recording still looks okay though, so I think we're gonna be all right. Face cam. Face cam. I'm back. Okay, cool. So where was I? So what we want to do is dig into what these messages mean a little bit, try to understand how we work with them, and try to understand how to like figure this stuff out for yourself, basically. So data 1, data 2, data 3. This is all we get. All the musical information we can have is encoded into these 3 numbers, and they're from 0 to 128. They're not big numbers. So if I press a key, I'm holding it down, I can see these values: 144, 72, 67. And if I release it, I see 128, 72, 64. It's interesting. This is consistent, this 72, which is good, because it seems like that number refers to the note that I'm pressing. And I can also see from pressing a bunch of notes, these 144 and 128 seem to be pretty consistent as well. They're just alternating, right? So 144 seems to be pushed down, 128 seems to be lift up. And I can see, if I do a couple little experiments, if I push very lightly, that third number is very low. If I push really hard, that third number is really big. And we can discount the third number on the 128 pass, because note up, lift up, doesn't have velocity. But if I press down hard, sorry, I pressed a bunch of keys then. Press down hard, I get a high number like 123. If I press down really soft, I can get a really low number like 1. So that third value seems to be velocity. So this is good to know. This is good information. You will see other stuff fly by from time to time, like I have a pitch bend, so that's 224 seems to be my pitch bend. I have this mod, we can implement some of these maybe. I also have like this keyboard has like aftertouch, which I don't really understand like how it works, but I thought it had polyphonic aftertouch, but it doesn't seem like it does anymore. But it has this stuff built in, so you will see other numbers fly by. It's not important to understand what everything is. It's okay to just like focus in on the one thing that you care about at that moment. And for us, that's going to be playing notes. So that's this 144, 128, and these other values. And if I go to every music tech student's favorite site, which is the Midi message table, we can get a little bit more context about this. So let me get this guy up. We get a little bit more context of what these things actually are. So I scroll down a little bit. Expanded messages list by status byte. So here we have status byte, data bytes. The status byte is that data 1, Midi message.data 1, and the data bytes are data 2, data 3. And it's confusing because they write the status byte in binary and hexadecimal. We're humans, not computers, so we like decimal, so we can just look at this last number. But we can see, okay, 128, that's a note off event on Midi channel 1. And for that event, the second byte will be the note number, and the third byte will be the velocity. That's very good to know. If we look at our 144, there we are, channel 1 note on, no number, no velocity. So that maps to what we thought before. There's some other things kicking around. So, 60 is polyphonic aftertouch. I don't know how it works polyphonically, but it's aftertouch. Once you get up higher, up into 176, we get into like control change world. And then we see table 3 for these other values. Aftertouch, pitch wheel, sound controller, effect depth. Once you get into this sort of world, it's important to note that this is kind of predefined values for old hardware synthesizers. For us, this doesn't really make any difference. We'll just get these numbers in and we can do whatever we want with them. But you'll notice, like, if you plug a MIDI keyboard into Ableton and you move the pitch wheel, like, it'll work. It'll do the pitch bend. And that's because some of these things, like the pitch wheel, is like a defined thing that everyone's kind of agreed, okay, 224 will be the pitch wheel. So if I hear something on 224, I can assume it's pitch wheel. We could, of course, in Chuck do whatever we want with 224. It doesn't have to be pitch, but it's good to know. And it's good to know if you want to send some pitch wheel data out, you can look at this table and see what MIDI note you need to send. But all we care about for today is this 128 is note off, and 144 is note on. So let's do some work with that. So let's real quick throw up a sine Oscus and chuck it into the DAC. I'll set its volume a little bit lower. 1.5, chuck to s.gain. And I'm going to say if message, let's like not even care about the oscillator right now. Let's just do a little bit more kind of moving. So if message.data1 equals 144, it's a note on, right? So we'll log note on. And we'll do an else if message.data1 equals 128. We will log note off. See if this is any good. Good, yeah, note on, note off, note on, note off, note on, note on, off, off. Working perfectly. This is going to derail us for 1 second, but if I don't say it right now, I'm going to forget. So there are some keyboards out there in the world that will not send 120 value status byte 128 for a note off. They will send 144, so a note on event, to the same note, but with a velocity of 0. So you may see that on your device. I don't see it that often anymore, but it does happen. So if you see something like that, accommodate for it. Write the if statement in a different way to be checking for that zero velocity rather than that status byte. Just so everyone's aware that can happen. It does happen. Okay, back to what we're doing. So we have this node on, node off. And I've said already, right, that message.data2, that's our note. So 69, 68, 67, 66, 65, right? That's my middle C there, 60. So let's just do a super simple sine oscillator. And when we get a note on event, I'm going to say message.data2, chuck to s.freq. And this is a Midi note, right? So we need to wrap that in an std.m2f message data2. So that'll convert it from Midi to frequency, right? Okay, so we've got something playing already. Turn that racket off. This is working great. Let me bring this down an octave. This is working. And it's sort of in tune, like obviously it's just notes, it's just data. It's in tune. And it's just MIDI, so this controller can do everything else it normally does. Like I can do my octave button works. If I had a sustain pedal, that would work. We're not doing any note off, but that would work too. If I do the arpeggiator, that works. It's great. Works perfectly. What we want to do now is we want to account for note off as well, and then we want to get into some ideas for handling polyphony. We're going to do simple ideas for polyphony. If you want to do more complicated ones, you're all capable of solving these problems. So I'm just going to show you kind of like the basics to get you going. So we have this. I want to account for node on and node off a little bit. So what I'm going to do is I'm going to start us off at 0 gain. If we get a 144, I'll say 0.5, chuck to s.gain. And a 128, I'll say 0, chuck to s.gain. Chuck our tester. Cool. This is perfect. This is working great. So we have that. It sounds like crap and it's monophonic, but we're getting somewhere. We could, of course, also use our velocity value somehow. So I could do, rather than 0.5, what if I did, oh God, math. If I did 128 or 127 divided by message.data2, no, the other way. That was close. Message.data2 divided by 127. Right? Yeah, divided by 127. And I'll multiply that by 0.5. This is one of those times where working with Midi, or I mean not with Midi, but like I said on the first day of Chuck, it's one of those times where we are plugging some math into gain that may be wrong. So this is a good time to bring the volume down on Chuck. I'm going to do it for you. You don't have to mute me. But bring the volume down, run it, and slowly bring it in. Don't just like blast yourself. So I'm going to run this. Oh yeah, but see, I did fuck up the math. but luckily we made it. I did data 2 and I went through data 3. Okay, so again. Okay, it seems to work. The scaling's a bit wrong, but like very softly. Very loudly. Works. We can use velocity too. This is great. It's great news. So, this sounds crappy, monophonic. So I want to discuss a couple of ideas for doing polyphony. Both are very easy, very simple, and have different pros and cons. The first one, I really should check the time when I start these videos, otherwise I don't know how long they are. So the first one, rather than declaring our sign-offs here, is I'm going to declare a function. Fun void play note. We'll accept an integer argument of note. And this function will basically be one like ephemeral voice. Like it just like fires and then dies. It has no light. You don't keep an oscillator alive. It just dies. It just plays one time and then it's gone. So every single note we play is a specific instance of this function. So I'm going to do sin ask s. I'm going to chuck it through an ADSR to give us some amplitude control, and I'm going to chuck it to DAC. Chuck a low gain to S for now, 0.2. Chuck to S.gain. And I'm going to do 10 ms chuck to E.attack time. And maybe 1 second chuck to E.release time. Then I would like to E.key on. E.attack time, chuck to now, and then E.key off, and E.release time, chuck to now. Okay. So hopefully now, if I spork play note with an argument of, oh, you need to pass that note in as well, right? So we need to do std.m2f of note, chuck to s.freq. And then if I pass in note, which is Midi, message.data2, if I do that on key on, we don't need to do anything on note off, because our thing only lasts for 1 second. It's not going to do anything. So let's try this, see if this is going to work. ADSR is no member release time. It looks like I spelt it wrong. Okay, good, we're connected. Okay, good. It seems to work. So we have polyphony. You have to excuse me not being a keyboard player. But it works. And this, I believe, is a great way of doing this kind of thing. It has one very important problem that programmers, well, it has two problems. One of them programmers hate, and I think it's fine, but we'll talk about it. The other one is an actual kind of musical problem we'll probably need to address. So the first one is that this has, this function, this way of playing music, where we just kick off a note anytime we do something, we kick off a function anytime we do something, has what's known as a memory leak. And what that means is that over time, we're creating, every time we play a note, we're creating these oscillators, this ADSR, and we're never really destroying them. And so over time, we're gonna run out of memory eventually. It's likely that on a reasonable computer, you can be fine. You can do this for a very long time before you run out of any sort of memory and have any performance problem. So for testing and for development and for experimenting and maybe for like playing parts in or something, this is totally fine. If you're going to do an hour-long set and you need everything to be rock solid, if you're going to be doing something else that's very computationally expensive at the same time, or if your individual voice is very complicated, sometimes that happens, and I don't know why. There's a ghost in my computer. If you're going to be doing that, then you may not want to use this approach. Or if you're going to work with samples, don't do this with samples, because then you have to do a read every time. You have to like load the file into memory. That's going to be very expensive. So, but if you're just working with sine waves or, you know, working with oscillators, basic synthesis, this is fine. You know, I can play this for an hour and my computer's not going to die. I haven't tried, but I think you get a long time. That said, the more important musical problem is that I have no sustain here. This is like a percussive sound, right? Like, I just hit it and it goes. I can't like hold it down. I can't have any sustains. This isn't working. This is working like a piano. This isn't working like a synthesizer, like an organ. So to get things to work that way, it's pretty similar. It's pretty simple. I'm actually going to comment this whole thing out. I'll copy the loop again, but I'll clean this up when I give you the code. But I just want to keep it there so that I can see it, or so that I don't forget about it. So what I want now is, rather than, I've got an itchy nose. Setting a bad example and touching my face, but I promise I haven't left the house in a week. So rather than using a function, we're going to use a class. So if I create a class called voice, and voice is a sine oscillator, it's going to look much the same. So it's a sine oscillator, S chucked through ADSR, E chucked to DAC. I'll give S some low gain. And we'll say E dot attack time is 10 ms, and E dot release time is 1 second. So now let's do write a function called play, which accepts a note, std.m2f of note gets chucked to s.freq, and then it does an e.keyOn, but it doesn't do anything else. And then we'll write another function called stop, which just does e.keyOff. And now this class can handle playing something and stopping something over time, essentially. And what we want to do is I want you to imagine this is like, it's like a piano. We're going to implement this like it's a piano or an organ or something, where it's not like a vintage synth where you have like a voice chip, you have 8 voice chips, you only play 8 voices. Like, each key has an instance of this class. Each key has a voice, so we get 128 note polyphony. And it makes our code a lot simpler too, so we're just going to go that way. So I'm going to create a voices array. And it's going to be 128 values long. So 1 for each key. Imagine, for each Midi key. And then I'm going to have my note index, so I'll say int note, which is going to be message.data2, right? And I would like to do voices note dot play note. These don't need to be sporked. And voices note, move that outside. Voices note dot stop. We'll run this, and I can hold it down for as long as I like. And my on-off ordering works fine. And this is kind of the second approach to this. And this is more robust. Again, you know, you are, I suppose, creating unneeded things. You probably don't need 128 things. Like, you're never going to play 128 at the same time. So maybe it's a little wasteful, but it makes your code so much cleaner. So I would advise doing things this way. The only time you shouldn't do it this way is if you're doing granular. And basically, a thing to remember is that sound buff and sampling is probably not, it's not the most expensive thing you can do computationally, but it is the most expensive thing we can do as far as memory. So every time you load up a file into a sound buff, like, you need to make sure that it was worth it, because it's going to take up room in your RAM. So you could load 128 samples this way, and that'll probably be fine. Maybe. Depends how long they are. You can load 128 drum sounds or something, but you might not be able to load 128 like 6-minute WAV files. But you could load plenty of sounds like this, but I wouldn't do granular like this, where each voice has like 32 sound buffs in it. I would definitely avoid that. And if you're going to go that route, you can use the sort of voice allocation code we've already done in granular, where we have like an available voices array and a find next grain and all that sort of stuff. That's the approach that I would use there. I'm not going to go into that now because I think, one, we've already talked about it a bit. It's probably not relevant to most people, and it'll just make this video longer. So I think this is kind of the move, to be honest. Maybe we should like implement a few other small things on top of it just to get a little bit more interest going on. So we've already worked with velocity, right? So maybe we take velocity as an int, and we could do velocity maps to volume. That's kind of boring, I think. So maybe we'll do velocity maps to, so we'll do our little calculation, right? Vel, so what is it, 127. Yeah, right, so vel divided by 127. Chuck to float. And I'm going to use this to control the attack time of the envelope. Chuck to float ATK. I'm just going to log it just so I know that it's in the sort of range I want. Oh yeah, let's pass val in here. So message.data3 is our val, right? Good, so if I go hard, it seems to be pretty close to 1. If I go pretty soft, it's pretty close to 0. I might even go so far as to square this. So I might say ATK times ATK, chuck to ATK. And I know this is like a little weird, but what this does is it makes it like, means like if I press softly, I get low stuff, and if I press hard, I get high stuff, but I get less in the middle, which for me is good because I want kind of extreme variation. It basically, if you think about squaring, if you have a number between 0 and 1 and you square it, you make, you basically take this thing like this and make it like this. You give it this non-linear curve. And that can be really good in music. If we were doing audio, if we were controlling volume like this, it would also be important because that's how we hear. But I'm just doing it because it makes it sound better or control better or whatever. So we have attack now, and I might do ATK times 2 seconds chuck to E dot attack time. And now, oh no, we want the opposite though. We want 1 minus ATK. And now if I press very lightly, you get this quite like soft, kind of slow attack. If I press hard, we get hard stuff. that's kind of an effective idea. You see this sort of thing being done with like filter cutoffs and stuff. That sounds really great. That can be really expressive. We're not going to implement that now, but that can be really cool. And I'm going to do pitch bend and mod wheel real quick. I'll just do pitch bend probably. And pay attention here if you want to work with knobs and faders, because that's how this works. And I'll show you, I'm not going to look at the table to know what it is. I'm just going to log it and see what we get. So I'm going to log message.data1, message.data2, and message.data3. I'm going to restart. I'm going to move the pitch wheel around. So I can see that our pitch wheel is coming in on data 1 equals 224. And the data 2 seems to always be 0, and data 3 seems to be 0 at the bottom, 127 at the top, and 64 at a resting position. So let's play around with this a little bit. So if we just want to do a standard pitch bend, we could do something like if message.data1 equals 224. I'll leave a little comment saying pitch bend. Then we would like to, let's have all of these have a float bend, and this will be 1 to bend up, and so this is going to be a float which is from, let's say, -2 to 2. So we'll do a major second as our bend amount, -2 to 2, and it's initialized to 0. And when we do this, we're going to add bend to our notes that's being played. And we are also going to have a, how are we going to handle this? So it's going to need to, I guess it's also going to need to be keeping track. Maybe we can just handle bend outside. I don't know. Kind of winging this. So we have bend. We can add bend to this note. I think it does need to know about its own note as well. It's the only way this works, right? Let's just do it that way. Let's do it the simplest way. So let's say we also have our own internal note. Let's say note track to note. That's terrible. Yes, we have an internal note. I'll make this underscore note just so that it makes it easier for me to work with. And then we'll also have a fun void tick. This is my control rate tick. And this would be while one. I've taken to doing like 16 samp chuck to now for my like control rate loops, 16 samples, because that seems to be what Super Collider does, and that works fine. So 16 samp chuck to now, and I'm going to say bend plus note chuck to s.freak. So we don't even really need that anymore, or std to m2f. Now we don't even need that. So all this play thing does is set note and then start our attack. And we should also spork tick. getting some drop samples. This clearly is too fast. See 1 mil. That feels better. So now all we need to do is should bend change. Bend is this single value here. So what I would like to do, what do we say it is? It's message.data 3, right? We'll say, I'm going to use math.scalef here, or is it std.scalef? This is map. This is processing's map function in Chuck. Rather than doing the math here, I'm going to do it this way because it makes more sense to me this way, and I think it makes more sense just in general this way. So we have an input, which is message.data3. Its low value is 0, and its high value is 128 or 127. And I would like it to range from -2 to 2. And I'm going to chuck that to bend. Cool, this works great. I can do my like do some vibrato. Love it. So that's how you can do pitch bend, and importantly, that's how you can do anything in sort of control change world. If I go back to the Midi table, Midi message table, I'm not going to get my knobs and buttons thing out because it's just going to take too long. Where's the proper table? Where's the one I was using? Oh, Midi. What you'll see is that your stuff, your kind of knobs and stuff are going to come in on, it's going to be something like 176. So it'll be control or program change on channel 1. So control change, channel 1, might be something like that. And then it'll probably be like, this second one is the note and this is the value. That's how I'd expect it to work. But what I would do is just plug your MIDI controller in and then just twist every knob and just see what the numbers are and just write the if statements. That's the easiest way to go. But I will make sure you all get this code with your full sequencing and your pitch bend and stuff like that. Polyphony. And hopefully this is of use. The assignment, if you've gone this route, gone the Midi route, the assignment will be essentially, obviously you're going to write some code that does some Midi stuff. You know, if you're in keyboard world, write a voice class, do something like this, write a little synthesis thing, map the pitch bend onto something interesting or velocity on something interesting. If you're doing knobs and faders, do whatever, you know, just write something that listens to Midi and reacts in an interesting way. It doesn't have to be huge or crazy, but write something. And what I have to ask you to do, because obviously I won't be able to use the thing you write because I won't have your controller, is please just like make like a 20-second video. Like literally just get your phone out of your pocket, hold it over the thing, and tell me like, okay, so I wrote a voice class, sine waves, your velocity controls the attack time, and the pitch bend works. Just like say something like that on a camera, show it happening, and submit your code with that little video, and then we should be good. That's all I need from everyone. But I will need you to submit some sort of video. So hopefully that's cool. I will see you all on Wednesday in our little chat hangout. And yeah, stay safe, have a good time. I will talk to you all soon. Bye.